On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at one more example of a derivative. It's going to be a rational function. We're going to do it the long way, just as we did two previous examples in another video where we took the definition of a derivative, we found the derivative of a linear function and a quadratic. Very soon, you will be able to do these without doing it the long way, but I'm pretty sure your instructor is expecting you to know this. So now we have a rational function, and not only that, instead of f of x and f prime of x and stuff like that, sometimes you may see different function notation. S of t, very common for what we call the position function. Then you'll have a v of t and an a of t later on as well for velocity and acceleration respectively. So what I've done, we want to find s prime of t. I've just taken these f's. That was our function back here. Now we have a s function. So I replace the f's with s's, and I replace the x's with t's, function of time. So very similar to the previous video, to find this derivative, we're going to find the limit as h approaches 0. And this right here is telling us to take t plus h and plug it into the s function wherever we see a t. So I'm going to take this function, I'm going to take t plus h, and I'm going to plug it in right there. Looks a little something like this. So here it is. And notice this thing right here in red, 2 over t plus h minus 3, is the same thing as this, 2 over t minus 3, except I'm taking that t plus h and I'm replacing that t with this. That's exactly what I did here. And now we want to subtract s of t. Well, s of t is the exact same function we had given to us. So 2 over t minus 3. And then all of this is over h. So not only do we have different function notation, but we have some algebra that can be a little bit of a pain to figure out. And we can't take 0 and plug it in. We have a 0 in our denominator, h approaching 0. So one way to get rid of what we have here is a complex fraction. You know, we got fractions and then we have over another fraction. What we can do is we can multiply the top and bottom by a common denominator. So looking at our denominators here, we have t plus h minus 3. We have t minus 3. And then we can think of this h as being over 1. So a common denominator, a way to quickly find one, and in this case it's the best way to do it, we can take this piece times this piece times that piece. Well, luckily that's a 1. So let's multiply the top and bottom by the following. So what is this? Well, what I've done is I've taken that long factor there and that factor there, and I'm multiplying the entire top part by that common denominator, and I'm multiplying the bottom part by this common denominator as well. Now the 1, we don't really have to worry about multiplying by 1 since we're not changing the value of it. But what I want you to also notice is that this thing right here in green, we're really multiplying by 1. And whenever you multiply something by 1, you don't change the value of it. Well, why are we doing this? If we distribute this stuff, if we take this stuff and we multiply it by this first fraction we have here, what's going to happen is we're going to get rid of this t plus h minus 3 with that one there when we multiply all of this right here. When we multiply it by this first fraction, the t plus h minus 3 will cancel out here with that one, and that's going to leave us with the following. This is what we have left when we distribute all of this to this fraction here. Again, all I have left is the 2 and the t minus 3 because this factor here canceled out with that factor there. Now let's not forget our limit as h approaches 0. And now let's repeat this for this next one. We're going to distribute all of that same stuff in this purple oval here. We're going to multiply it by this second fraction, and it's going to do something very similar, except now we're going to have the minus 2, and we're going to have the t plus h minus 3 left. And the reason why that's the only piece we have left with this minus 2 that you see down here is because this t minus 3 will cancel out with that t minus 3. So what we've just done there is up top, all that distributing that we just did, it got rid of our fractions up top. And now at the bottom, you know, I mentioned this thing over 1. We don't really have to worry about that. What do we do at the bottom then? We just take h times this junk. Now, We still can't plug in 0 because we're going to have a 0 down there, but hopefully through some simplifying, we're going to be able to get rid of that h somehow or another. Let's see what happens. So we have the limit as h approaches 0. I'm going to distribute across the top 2t minus 6, and then distributing this negative 2 times this stuff. And again, all I did was distribute my top stuff. The bottom stuff, let's leave it alone for right now and see what happens. So looking to see what happens here, 2t minus 2t, they cancel out. Negative 6 plus 6, they cancel out. And we are now left with the following. And as you can see here, with this being the only thing we have left in our numerator, we can cancel out this h with this h, and now we should be able to directly substitute 0 into, well, there's only one more spot to plug 0 into right there for that h, and we will be left with our derivative. So what we have left when we can directly substitute this 0 into that h, up top we're going to have negative 2, because that h canceled out with that h, we don't even worry about that. Plugging a 0 into there, we still have t plus 3, but this little piece here gets knocked out, so we have t plus 3, and then we have that t minus 3 there. This is our derivative. This is s prime of t. Our derivative function, you may say, okay, well, what about these t's? What are we doing with these t's? If you looked back at the linear and the quadratic example we did earlier, the quadratic example still had a variable x floating around in it. And a lot of times that's going to happen when you find the derivative, or what we also call here the derivative function. You'll have a variable left over quite often. But the thing is here, we got rid of that h right there and right there, which means we could plug 0 into that other spot because that wasn't going to give us 0 in the denominator. And sure, it does leave us with some t's. We're finding a derivative function, and we're going to explore that derivative function even more relatively soon as we start comparing the original function to its derivative. And there you have it, one longer example of finding a derivative of a rational function. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.